So our next talk will be delivered by Ms. Saad Al-Bimania. Ms. Saad has many years of research experience working in an as a marine environmental specialist with the Ministry of Agriculture, Wealth, Fisheries, and Water Resources in Sultanate of Oman. She is an expert in marine ecosystem information and decision support with a focus on the Sea of Oman. Her talk will be Sea of Oman, Decision and Information System for the Coastal Waters of Oman. Ms. Saadi will have 20 minutes.
Yeah. Hello, everybody. I'm Suad, and I'm still not an expert in this. I'm still learning from others. Okay, today I will talk in briefly about the decision. This is a project about decision and information system for the coastal waters of Oman. The abbreviation DISCO. So maybe you will hear from me this abbreviation. First of all, this is a project, and we started in last few years, and I will talk about this later. Just go to the next step, please. First of all, I will talk on general demographic country information. As you see in the map, Oman has a long coastline. It's about 3,165 kilometers, and it is surrounded by the three sea, Arabian Sea, Sea of Oman, and Arabian Gulf. So it is extremely rich in fishing grounds, and fisheries is playing a very significant role in Oman income. We are working in the ministry as a Marine Science and Fisheries Center, which is the main role is the research center. So we are dealing with most of the research related to the marine and fisheries. Going to next slide. And we have cooperations with the national institution and international. This is the list of some of the institutions in Oman that's also study HABs, and we have sharing some projects also in harmful algal blooms monitoring, mitigation. These are Environment Authority, Maritime Security Center, Ministry of Health, Civil Aviation Authority, and Sultan Qaboos University. And the next slide, please. The international organization also, we joined with them in different projects and research. Some of them like the IOC, the Intergovernmental Oceanographic Commissions of UNESCO, the National Aeronautics and Space Administration, the NASA, also a regional organization for the protection of marine environment, ROBME, National Oceanic and Atmospheric Administration, NOAA, and International Atomic Energy Agency, IAEA. So all of these are cooperation since the last long time with our ministry, and actually we learn a lot during these projects and these cooperations, and we are joining with them in different workshops and conferences, and we are sharing a lot of information. Next. So why Oman need an early warning system for harmful algal blooms? As you see, this is a new photo for algal blooms in Oman Sea. It's since maybe three months. I'm not sure, but it is in 2021. Next slide. So why Oman need this early warning system? Over the last decade, Oman experienced massive outbreaks of harmful algal blooms, and during our research and data from field and satellite from the last years, it shows that the Sea of Oman and even Arabian Sea becoming more, the HABs is becoming more widespread and intense in this sea. So we need to manage and need to know, to study what is the reason behind that. And So these outbreaks, why we need to study this? Because these HABs can pose a significant threat to coastal resources, water quality, public health, tourism, and the operational capabilities of many coastal industries actually that affecting from these HABs. And also maybe there is an affected countries that they are in bordering with the Oman Sea or Arabian Sea. So that's why we need this early warning system that's providing the timely advisories to the stakeholders and also public for the public and for the health sectors and for tourism, as I said, and for also other coastal resource managers. Next slide. So we have here in the center doing periodic monitoring for the harmful algal blooms in Omani water. And we have this system, which is decision and information system. So firstly, I will talk about the monitoring of harmful algal blooms. Go to next slide. First of all, the first record of HABs in Oman, it was in August in 1976, and it was along the coast of Salalah in Dhofar in the south region. And that event caused a lot of deaths of fishes. And laterly, these events we have recorded in very close intervals. That's since 1988. So we start to record these events every year since in the late of 18th. And most of what we have observed and during our studies, we observed that most of these species are non-toxic. And all the cases that recorded, we have a mortality of the marine organisms because of the either to the lack of the dissolved oxygen level or excess of ammonia in the sea, or due to the cloaking of the fish gills that caused this death. And also in 2008, it had been a bloom was recorded. It was a very huge bloom extended from Musandam to the Arabian Sea. And it caused a lot of effects, very strong effects in fisheries. It caused a lot of mortality, and also it affects the aquaculture, tourism, and it lasts, I think, around about 8 months, or maybe more than that. And it was a red bloom. Next slide. So during that time and until now, we are continuing in using the latest modern technology in order to monitoring these events. And we are using here some of the remote sensing satellite images, try to use some of the softwares that we can manage, or we can extract the data, then we can make the validation with the in situ data, and all of this to predict the occurrence and to try to minimize the effects of the harmful algal blooms. And also we make a lot of monitoring programs, like going to the fields and try to survey the area if there is an event or not. Or sometimes we receive calls from other people that if there is an event happen. So we have like a team to ensure that we have a rapid response if there is HABs events happen in somewhere. So we try to make sampling, make analysis, and also we can publish the awareness for the people. So if there is a huge bloom, so we have to even through the other ministries, cooperations through magazines or newspaper or other social media, that there is a bloom. So have your precautions in the sea. So tracking of this bloom using different models, different technologies, we try to identify the affected locations and alerting the affected communities and fishing village. All of these steps and monitoring programs, we try to develop it, and we try to see others countries and take information and sharing what we have and what they have, and this is the steps that we have used, and we still, and we are going now to a next step. That's we have this information, so we have to start a system that can give us an early warning, using models and using supercomputers, for example. So we are talking here about the decision and information system for the coastal water of Oman. I just briefly give you a background. What is this system? This system is an operational HAB forecasting and decision support system. First, we started this project in 2016. It was in collaboration with Columbia University. With the research was funded with from NASA, and we have some experts from U.S., from also Southern University of South California, and we have from the Navy, U.S. Navy in Mississippi, and all of this we have like collaborations and do all this analysis that I will show you later in this presentation. For some issues, the project end and maybe in 2 years, and we are now in 2022. We preparing ourselves to start again this an operational early warning system to be in Oman, to be in an Omani operational early warning system. So I will now explain what this system is doing, what is the aim of this system, and I will give you some examples of the output of this system. So what is the general aim of this DISCO system? Is provide the information, the future prediction about the coastal fisheries resource, evaluate the effects of climate change, determine the ideal locations for fish farming activities in Oman coast, sure. And all these use new technologies and numerical modeling, remote sensing systems to have also a real-time forecasting of atmospheric and sea state conditions. Also, we provide through this system a real-time forecast for the outbreaks of HABs. This all based on the information or the data from could be from the satellite and from others, could be from other resources also. Go to the next slide. Okay, so DISCO architecture or the platforms. Actually, DISCO is consists of mainly of 3 parts: the DISCO core, DISCO Web, and DISCO Easy. DISCO Core, which is the responsible for ingesting, producing, and archiving data. And this is the figure showing, or the diagram showing that how it could be. The DISCO Core in the upper right is using the ANCOM cosine model from it's used for the supercomputer in the US Navy. Actually, there it ingests the information or the data from satellite, from coastal data, so other coastal data sources, and it will transfer later to the DISCO Web or DISCO Easy. So what is DISCO Web? DISCO Web is the web page that which deliver the information for people, for the clients, for the scientists, for the stakeholders, or other people who are interested in this information. So the DISCO Web could be in any websites or in mobile phone as application, or could be in any laptops. For Disco, the third one is the Disco Easy, which is the easy. It means the environmental analysis system. This actually a system or a software which is highly interactive and in-depth analysis using advanced GIS, Geographic Information System. So the processing and the system control and the analysis, it could be in this software, which is called Easy. In this, just one more things in the previous slide, please. In this diagram, it shows that there is a collaboration between the Omani support team and there is an US support team. And this is could be in the coming also project. It will happen also, but later we are planning to be. We can deal with this system in case we don't have like a contract with other experts. So this is the sharing of the experts from the other expert US support team. The next slide. This is the example of how the output from the Disco core, which is coming from the supercomputer, how it shows the map or the output figures. The first one from the left, it shows the sea surface temperature. In the middle, showing the sea surface height, and the right one is the chlorophyll concentration, all with surface currents. It's showing this is actually the simulation, showing the simulation of this data with currents. And unfortunately, because here I will have a very high size, I couldn't be able to put this simulation in the presentation. So this is the example of the output. Go to another example, next slide. This is another one, also showing the same type. It depends on the data that you required to put in your output. So here we can see if it is moving, it will you can see the simulation or the movement of currents with the data, with even sea surface, how the sea surface temperature is changing, or the sea surface salinity, or even chlorophyll. Here we don't have one of them is the chlorophyll, but even with chlorophyll, you can see the chlorophyll, how it is moving during the couples of days or 1 week, for example. So you can use the historical data, by the way, to see how it moving with the currents. Another slide. About the Disco web. This is how it looks like. It should be ready for the clients, for the stakeholders, for the public people also. They can just take the images, they take the figures. It gives like automated near real-time analysis. As I said, figures, animation, you can compare between them. You can get the validation of this data, and with your data, field data in the same locations with the same period of time. Another slide. This is also an example of the output of the Disco Easy. We can use the Disco for simulating and for tracking the fate of some. For example, in this figure, in the left one, it shows the oil spill from the two tanker incidents. It happens in June in 2019. It is between Oman and Iran, and there is like an oil spill. What we do here, they add the drifter to the system, to the location of the spill, and we just move it with the current data up to 7 to 10 days, and we see the distribution, estimate where it will go through the currents movement. It will be it will reach to the, for example, to Muscat, to east or west of Oman. So you can see the movement with currents where it will be. This is a type of early warning system. The other figure also showing the Kayar cyclones and followed by the Maha cyclones. It happens also in October 2019. So this is how we can use this simulation in this system, how we can predict the final destination of the events. Okay, next slide.
Excuse me, Ms. Saad, do you have 1 minute for your presentation?
Okay. This is also an example of the output of the Disco Easy. It shows you, for example, here we have oxygen concentration, the blue one in the up. We have chlorophyll concentration, we have the currents. It's the same idea. So go to the next slide. Okay, now what is the current capabilities within the Disco? Actually, Disco is provide, as I said, products. It depends on the data that we get it from the environmental sources. For example, we have it from NOAA, from NASA, from Operation Global Models, which is US Navy, from any other sources, from satellites. We can use this historical data. For example, we have data of 7 years or 10 years of historical environmental data, and we can use also the present data, what we have it now, and we can predict for up to 10 days in advance. So this is the role of this system, how we can predict or forecast for the coming few days. Monitoring HAB's outbreak in the coastal area of Oman. So it is the main focus in this in the current time. It is the main focus of this system, and in future we can also add others capabilities within this Disco to have another applications. Go to the last slide. What is the significant benefits from Disco? As I said before, it's serve the needs of a diverse range of infrastructure development activities in Oman, which can support the blue, or can transit Oman to a blue economy. Also, the Disco has the capability for the coastal aquaculture and fisheries management application. It can add something in this type of applications. Also, the ability of Disco to predict hypoxia and HABs, not only for forecasting the fish kill events, and you can also know what is the reason behind that. Just a little bit back. Also, the benefit of this system is to have effective monitoring and forecasting system that can benefit other sectors like desalination plant, fish farming, and other relevant authorities. Also, it can be as a database or a repository that have a lots of data for the historical and for the coming years. So as I said, we have a lot of applications that we can use it for this system, other than the prediction of HABs. And that's all. I tried just to finish quickly, and thank you very much for listening.
Thank you, Dr. Saad, for your marvelous work. Actually, it serves the purpose of this workshop is for knowledge sharing between the all GCC and the entire world information on the HAB. So we learned a lot today from your procedures in Oman, how you respond, how you forecast the HAB events, and we're looking forward to collaborate with you to learn from your experience. We will open a Q&A session now, briefly, so then we will break. Any question to Saad?
Yeah, there is about the resolution. Yeah, it is a very high resolution. If it depends if the sources is coming from the supercomputer, it's reached to, I think, 200 maybe meter resolution. It's very high resolution. But if you have the sources from open sources like Ocean Color or others websites, it will be, I think, around 1 kilometer for sometimes 4, sometimes 9 kilometers. So it depends from the sources that you have. But we are here focusing to have firstly from the supercomputer because it will give us a very high resolution.
We have another question from Narish. Does artificial intelligence helping to monitor algae bloom? How can we monitor algae toxic and predict that there could be bloom in the year days?
Yeah, actually, it depends on the algorithm. If we have a specific algorithm to our area, Sea of Oman or Arabian Sea, yeah, we can. And there is some research from the US team. They are trying to find something that we can distinguish between the type of species in Oman. But still, we didn't do it here in Oman, actually.
So we have Alejandro Clement.
Which Ocean Color algorithm use it? You can use any algorithm because from Ocean Color, it is an open sources. So you can use chlorophyll concentration, or depends what is available there. You will find it because we have global data.
Perfect. Thank you. Any more questions? Let's wait for any more questions.
How long does algae bloom stays in the water? We cannot know exactly because this is a natural thing. Sometimes it depends on the climate change and the weather. And yeah, it sometimes it stay for weeks. Sometimes it stay just for a few days. Sometimes it's continue for a month or more. So it depends. It depends in the factors that affect the blooms growth, I mean, like that.
Good. One more question, Abdullah Hassan. Did algal blooms affect the offshore fish farming in Oman?
If it is actually most of the time the algal blooms is going to the coast and moving, not staying for a long time. It depends on the current sometimes. But exactly if it is affected, if it is too much, maybe it will affect. But I cannot say, yeah, it's affected or not. Maybe these questions you can transfer to more specialist people with the fish farming people.
Good, thank you. So our next talk will be the status and trajectory of aquaculture in the Arabian Gulf and Sea of Oman. It will be delivered by Mr. Patrick White. Mr. Patrick has 40 years of experience in the aquaculture industry and the governmental research. He has helped pioneer the aquaculture around the world, including Asia Pacific and the Middle East, and is a long-standing consultant for the FAO. So we're gonna, I think it's pre-recorded by Mr. Patrick.
Hello, my name is Patrick White. I'm giving a brief presentation on the status and trajectory of aquaculture in the Arabian Gulf and the Sea of Oman. The Arabian Gulf and Sea of Oman are generally suitable for aquaculture in terms of fish and shrimp pond farming and fish cage farming. The salinity is quite high at 40 parts per thousand in some places. The temperatures are suitable, although in the north the temperature fluctuation is quite high. And the residual currents and tides are suitable for supporting fish cage farming. However, there are some constraints to aquaculture development. The bathymetry is quite shallow in the southern and western areas of the Gulf, which means that cage farming needs to occur quite far from the shore. There are some strong wave action in the south of the Gulf, which means that cage farming structures need to be stronger. There are also quite high chlorophyll levels at different times of the year, and this can be problematic for algal blooms. And there is a lot of marine traffic in the area, so there can be conflict between aquaculture and navigation. Aquaculture is important globally as fisheries has stagnated, and it's aquaculture that is producing the seafood to supply the demand for a growing population. Traditionally in the Gulf area, wild seafood fisheries is preferred over aquaculture, but it is becoming more accepted and it has increasing popularity. Some of the Gulf states have stepped up their efforts to promote aquaculture development in order to meet their demand for fish, reduce the imports, and have food security. Although it is a new and relatively small industry, there is the start of some heavy investment in fish farming. The contribution of aquaculture towards country GDP is quite low. 0.07% in Saudi Arabia, 0.06% in Iraq, and even less in the other countries. Saudi Arabia, UAE, and Oman have a strong policy for aquaculture development, with incentives to attract private sector into fish farming. Aquaculture is seen to be important because it can supply seafood from the large coastal resources. It's revitalizing the coastal areas, and it supports a number of complementary businesses, such as feed supply, fish processing, fish, seafood, transport and marketing, as well as the support services in terms of research, technology development, innovation, and education and training. Aquaculture in the Gulf states has been increasing rapidly since 2015, with the largest producers being Iran, Saudi Arabia, and Iraq. In the case of Iran and Iraq, some of this production is from freshwater, and in the case of Saudi, some of the production is from the Red Sea coast. The majority of production in brackish water and marine systems is from coastal pond, shrimp pond production, particularly in Iran. In Saudi Arabia, the majority of the production is shrimp and with some fish production in cages, but it's mainly along the Red Sea. In total, the brackish water fish and shrimp production is around 55,000 tons, and on the Gulf and the Sea of Oman, around 25,000 tons. The main culture systems are saltwater or brackish water ponds for shrimp production, using aeration to allow higher intensity, and also smaller line ponds for the nursery stages before growing out in larger ponds that have been built in Sabkha areas. For fish farming, it's large circular cages made from high-density polyethylene, and these vary in size between 20 meters and 80-meter diameter, depending on the size of the farm and the exposure and the water depth. Fish and shrimp hatcheries are required to supply the small fry and shrimp post-larvae to be stocked in the ponds and cages. Most of the Gulf states have developed their own hatcheries, and in Bahrain and Kuwait, they have specialized in hatchery production. There is a large range of species being grown in aquaculture, ranging from barramundi or Asian sea bass, gilthead sea bream from the Mediterranean, miga also from the Mediterranean, the local sea bream sabaeity, and shrimp. There are also a number of potential new species which can be grown and are being investigated at pilot scale at the moment. These include the grouper, pompano, cobia, rabbitfish, and oysters. The Gulf states are carefully planning future aquaculture development using a number of tools. One of these is marine spatial planning to avoid future conflict with other users of the coastline, and also establishing aquaculture zones, which are specific areas for aquaculture production. 3 countries have developed an aquaculture atlas: Oman, UAE, and Saudi Arabia, identifying the suitable zones for aquaculture development. I will now make a brief tour of the Gulf states, explaining the aquaculture development in each one of them, starting with Oman. Traditionally, Oman has had rich fisheries, but recently that has been decreasing. And in 2013, the Ministry of Agriculture made strong policy for aquaculture development. Now there are around 23 tilapia farms and 1 large fish cage farm producing European sea bass and gilthead sea bream. The country hopes to produce around 200,000 tons of fish in 2040, and it has pledged more than $1 billion to the sector to try and reach their target. Seafood is important in the UAE because of the strong demand for seafood and preference for eating seafood, but nearly 70% of the seafood is imported. There are 5 commercial marine fish farms, and there are plans to build a specialized feed mill to supply those fish farms. The country's Ministry of Climate Change and Environment is promoting aquaculture strongly and is easing the permitting process and supporting scientific research for aquaculture development. Bahrain has an active aquaculture sector and has specialized in marine fish fry production. Recently, the ministry has allocated certain areas for aquaculture development for recirculated aquaculture systems onshore, so using tanks to grow fish with recirculated water. And there is a plan to modernize the National Mariculture Center and upgrade capacity for fish fry production. Saudi Arabia is already a large aquaculture producer with more than 60,000 tons production in 2017. The majority of this was in the Red Sea, producing shrimp in ponds and fish in cages. The government has an ambitious plan to produce more than 600,000 tons by 2030, and the ministry is encouraging this development with incentives and investment in infrastructure. Saudi Aramco has built a large fish hatchery on the Gulfs, and this is about to become operational. Kuwait was one of the first countries in the Arabian Gulf to look at aquaculture development, and the Kuwait Institute for Scientific Research has been conducting research on fish fry production, as well as improved feed formulation and disease control. But there are limited resources for aquaculture development in terms of pond or cage farming. Iraq has a large freshwater aquaculture production, but very limited marine aquaculture. It has a limited coastline of only 20.5 kilometers, but it is investigating the possibility of developing aquaculture in the marsh areas along the banks of the Euphrates. Iran has both freshwater production with rainbow trout and marine and brackish water with shrimp production. It has a large shrimp production of 32,000 tons in 2017, mainly produced by small family-owned farms. And there are opportunities for intensifying and expanding marine shrimp production in Iran. These additional nutrients can have an impact on water quality and can contribute to development of algal blooms. The Arabian Gulf and Sea of Oman are naturally prone to algal blooms, and this is a risk for fish cage culture in particular. The blooms can kill fish in a number of ways. One is during algal blooming, oxygen is required during the night, and this strips oxygen from the water, and there's no oxygen for the fish to survive. The second way is the algae can clog the gills. That makes it more difficult for fish to absorb oxygen, and again can cause mortalities. There have been several algal bloom events that have affected aquaculture. One of the first was in 1999 during a red tide in Kuwait Bay, where elevated nutrient levels caused a fish kill. Another event happened in August 2008 until May 2009, which caused a large mortality of farm fish in the fish cage farm in Kuryat, Oman. This reoccurrence of blooms may become a persistent risk for aquaculture development in the future. Thank you very much.
All right. Have everybody back. Thank you, Mr. Patrick, for a marvelous session. I think Mr. Patrick can answer questions now. Is he available?
I can't see him in the list, Kisai.
Yeah, so he's not available.
Sorry, no, didn't seem to be there.
All right. I think.
Should we move on?
Should we move on to the next speaker? All right, everybody. Thank you again, and welcome back. Our next speaker will be our colleague, Dr. Shireen Sbai from Kuwait Institute for Scientific Research. Her talk will be Shrimp Aquaculture and General Aquaculture, an overview, challenges, and accomplishments. Dr. Shireen has over 18 years of research experience in aquaculture sciences. Her work focuses on shrimp farms and hatcheries. She has led multiple projects on shrimp aquaculture and has trained numerous experts and business entrepreneurs in the shrimp aquaculture sector. So when you're ready, Dr. Shireen.
Hello, hi, Dr. Oksai. Thank you so much
Hello.
for the kind invitation. And thank you for everybody for the organization and hosting this event. I don't know, I couldn't start my video. So I'll just use this microphone to present my talk today.
Go ahead.
So today I'm going to give just a brief introduction or review about the shrimp aquaculture in Kuwait and our achievements so far. So please, next slide. As Dr. Patrick has mentioned in his earlier presentation, Kuwait Institute for Scientific Research has initiated the aquaculture research in the 1983. KISAR conducted several studies on the hatchery seed production for our local species, the Semisulcatus and the Aphanus. We managed to achieve a good result, but it wasn't good enough to go to the commercial scale. In 2015, KISAR has initiated a project for government initiative to develop a technology for application at commercial scale for shrimp culture. And in this government initiative, we start to study new species, and the model species for this project was the venemi. And I'm going to explain why we selected the venemi. And we developed the bifloc technology for Kuwait for the shrimp culture. Also, we developed the seed production of the Aphanus and the bifloc, and just to check if there is any good progress for this local species. Next, please. Next. There is some animation here, sir. Another click, please. And another click. So this is just a few numbers. Kuwait, we produce locally around 1,260 tons of shrimp, and we imported more than this amount, around 1,588. We have zero culture shrimp, although there is some small projects started from the private sector, but unfortunately, up until now, we don't have any successful story for a shrimp farm in Kuwait. And I'm going to explain why in the next slide, please. Before I explain why we didn't have any success story for the shrimp culture in Kuwait, especially in inland, I would like just to give you a brief numbers or some statistical information about the import and the local capture in Kuwait. As you can see, over the years, the price has been increased. The quantity has been, for the local, has been decreased, and the importing has been increased. This is because of many reasons. One of the main reasons is also, of course, the population growth, but also we have other issues from the environment, pollution, and the big demand for the seafood meal as a healthy meal. So there is a big demand for the seafood in Kuwait, and for that it can show why the government has been focused on investing now more money on this type of project because of the high demand. Next, please. And Kuwait, as the rest of the world, the aquaculture sector is growing everywhere. And it will be the only solution for Kuwait in the coming few years to fill the gap between the capture and the demand in the local market. Next, please. So there is different types of shrimp culture system. The first one is the traditional extensive system, where they use the huge pond, the size between 3 to 20 hectares. And the density is very low. So when we're saying 3,000 to 5,000 per hectare, you are talking about maybe one shrimp in each 2 metric tons. So it's very, very, very low density. The problem with this method, click please. It has, click please. Yeah, the yield is very small. As you see, this is another type. It's also a huge pond, but a little bit improved. Semi-intensive, so the density here is a little bit more, but still it's not very intensive. So In this pond, the size range from 0.8 to 1, from 1 to 3 hectares, and the density is around 1 or 5 shrimp per cubic meter. And next, so this is the third type, and this is now the more common worldwide is the intensive method, especially with the new technology like the biofloc and the RAS. We can culture here from 200 to 250 shrimp per square meter, and you can see the big difference. In the previous ones, we just talk about 1 or 2, maximum number is 5. Here we are talking about 200 and 250 per square meter. The size of this pond or the tanks is a little bit smaller. And click please, next. There is another type, it's either pond or raceway. And the raceway is suitable for the countries that they don't have the perfect climate condition for shrimp culture. For the shrimp to grow well, you need to maintain a temperature between 28 to 30 degrees. So indoor, putting raceway indoor, this can maintain the temperature very well, and they can culture 3 or 4 crops a year. So this is the raceway. Next, please. Next, please. Yes. So what is the biofloc? Biofloc system is a recent innovative aquaculture technology. It's very promising for stable and sustainable production, as the system has a self-nitrification process within the culture, pond, tanks, raceway with 0 water exchange. So basically, the mixotrophic bacteria that it's grow in this system will break down the ammonia to the nitrite and nitrate, and will maintain the water quality without exchanging the water. So this is the concept of this system. Next, please. This is another graph just to clarify how this system works. So the excess feed or the waste of the shrimp, this bacteria will come and break down the ammonia that's produced from this excess feed or the waste, and break it down to NO2 and NO3. And this way, you don't need to exchange at all during the culture. Next, please. So in Kisser, we over this past 6 years, we studied this system and we studied different conditions. First, click please. First, we studied the seawater, and as you know, the seawater in Kuwait, the salinity is very high, 46. So we optimized the biofloc at 46 ppt. We studied the diluted seawater, 30 ppt, and the brackish water, 5 ppt, and the last one is the corrected brackish water, and this is the hot topic now that we are studying in Kisser. So we are correcting the brackish water to make it more flavorful, suitable for shrimp culture in Kuwait. Next, please. So inland shrimp farming has a relatively short history due to the fact that the groundwater is unsuitable for shrimp farming. Kisser has overcome this problem through scientific research at experimental scale. The hard success of such a unique technology has raised the bar to test the production at semi-commercial scale at one of the sites in Kuwait, which is called HAB site. This is located inland in Kuwait. Next, please. So there is a different solution to correct the brackish water. One of them is to add artificial sea salt. And for example, if you want to prepare a 300 liter or to make the water of 300 liter, you need to add 10 kg of this artificial sea salt. But as you see, the 10 kg costs $60. So although we can solve the problem, but this solution is not practical because of the high price of this type of the salt. Next, please. So we conducted a survey for the salt available in the local market in Kuwait. And among all this type of salt, the Indian salt, Swedish salt, and Kisser salt. Kisser salt is, we extracted the salt from the brine, and the Vietnamese salt. Actually, we found that the best salt condition was the Kisser salt and the Vietnamese, and we compared them based on the magnesium to calcium ratio and sodium to potassium ratio. Magnesium to calcium ratio plays an important role for the osmoregulation in the shrimp during the molting process. So in the seawater, magnesium to calcium ratio is around 3. In order to have a successful culture, we should increase or maintain magnesium to calcium ratio above 1. And if you look at the other salt, we are not maintaining this level. So that's why we selected the last two, Kisser, number 4 and number 5. Next, please. And this is a graph showing the improvement after using the magnesium salt. So the blue line is the growth of the shrimp without addition of the magnesium salt. And then the yellow line after adding magnesium to calcium ratio 1. The green one after adding magnesium to calcium ratio 2. And the red one is after adding magnesium to calcium ratio 3, which is similar to the seawater. And you can see the improvement in the growth. Also, not only the growth, you can see from the picture the texture and the quality of the shrimp also has been improved. And the most important thing, survival rate. So we managed to have a survival rate now. Before we just got with the control without adding magnesium salt around 10 to 20%. Now with the after addition of the magnesium salt, we maintained above 50%, which is excellent. So it can make this project more feasible for the farmers. Next, please. This is some picture for the training course that we conducted during the past few years. So every year we have a training course for the farmers just to give them an update. This field is still new and we're still studying our environment. So every year we give them some information, and we prefer that to keep them updated, because if they started early, they are going to maybe fail, and we don't want them to fail. So this industry will be less attractive for private sector. So we are we're giving them like more priority, because we know that these farmers can build this industry very well. For Kuwait, if we have 40 successful small farms, it can fill the gap for the food security in Kuwait. So every year we have a training course for the farmers. Next, please. This is also some of the training course that I attend internationally. So I've been exposed to the Thailand experience and Korean, and every country has its own environment. So we cannot just take any example and apply it to Kuwait. So we just learn from the other practice, but at the end of the day, we should apply what's suitable for our environment. So although Kuwait is not very good place for agriculture, but I believe that it is very attractive for aquaculture, because shrimp loves our arid climate, and they can grow very well all year round except winter season. Next, please. This is also some of the training. Next, please. And we also conducted some awareness campaign for by doing shrimp release for our native species. So in one of our experiments, we have an excess, after having some broodstock, we have an excess BLs. And then we decided that we should just do some shrimp release, but maintaining 2 million in a small hatchery, it was very stressful. So although we took over this initiative, but at that time it was very hard to keep this amount in our small laboratory. But it was very successful, and also give lots of information for the people. Nobody knows that this broodstock can spawn around 200,000 eggs or post-larvae. So this is type of awareness for the fishermen, that the importance not to catch this type of broodstock to maintain our shrimp stock. Next, please. This is also our the construction at HAB site. So we established an inland shrimp farm in Kuwait. As you can see in the picture, this is the raceway, the 3 raceway. It's at semi-commercial scale. Each one is 75 square meter. Also, we have an outdoor facility for the outdoor pond. In the next slide, please. Oh, okay, it's not there. Anyway, we have 2 outdoor ponds. The size of each one is around 1,500 square meter. This layout is for our next big project. It's a fish and shrimp production plant. As you can see, we have a production unit for shrimp, fish. We have a shrimp hatchery. We have a fish hatchery, processing plant, and feed mill. So all the scale is commercial scale, but it's only 1 unit from each. The idea is to have it as a demo for the investor, because nobody until now started their project here, private sector in Kuwait. So we start the first small scale farm at CHEP site for the small farmers, and this one, the layout is for the big company or the mega company to show them how successful is this production at commercial scale. And it's now at the designing stage. Next, please. The key discussion points for my presentation today is that the hatchery seed production of our local species is already achieved in Kuwait. In general, shrimp aquaculture industry is in the nascent stages in Kuwait. Magnesium salt has improved the performance for inland shrimp farming, but it's still not enough, because we only corrected the magnesium to calcium ratio. There is other minor elements that we didn't study and we didn't correct yet. So maybe after improving the other elements, we will raise the power for the survival and the growth rate. And last but not least, further advancement leading for commercial shrimp culture is still awaiting Kuwait. We still need lots of legislation and this encouragement for the private sector to enter and start this industry in Kuwait. And I think that this is the last slide. Next, yes. And thank you so much for this wonderful workshop. And I'm ready for any question.
Thank you, Dr. Shireen. Your work is very enriching, and thank you for resurrecting the shrimp aquaculture back in Kuwait, both on the research side and the benefit of the consumers and the entrepreneurs and the business side. And thank you. So we'll have open questions now for Dr. Shireen. Anybody have? So we have one question, Dr. Shireen.
Yes. So the first, I am interested in the reason why shrimps grow much faster with magnesium calcium salt addition. Any possible? Yes. The magnesium and calcium, not magnesium, magnesium to calcium ratio and sodium to potassium ratio. These two elements regulate the osmoregulation during the molting process in the shrimp. So if this ratio is not correct, the shrimp cannot molt, or after molting it will die. So it's very important to correct this ratio to maintain this process, the molting process.
Thank you, Dr. Shireen. Any more questions?